A useful technique for protein purification is exclusion chromatography, that considers the molecular weight of the molecules in a solution for their separation. It has two different phases: a liquid mobile phase composed of salts and a buffer solution, together with a solid stationary phase that don't react with the molecules of our sample. It uses a porous gel column that allows the molecules to be separated into three different types of molecules. The first are permeable molecules that correspond to small molecules that enter in the porous and pass slowly through the column. Then we have fractionable molecules that passes partially, and excluded molecules that correspond to those with a great size and that is greater than the pore. According to this, the behavior of the separation is distinguished with a free passage of larger molecules, while the small ones interact with the pores of the column as they as they are retained in the pores. The main advantage of size exclusion chromatography is the conservation of biological activity of our molecules, while a disadvantage is related with the differences of the molecular weight of our molecules in the solution, because we need to have a 10% difference in the molecular weights between them. The quantification is carried out by calibration curves, as we can see here, that relates the molecular weight of the components and their retention or elution times or volumes in the column. The first peak of the graph, as we can see here, corresponds to the large molecules, which do not fit into any of the pores, while the last peak represents the smallest molecule containing the solution, because they are retained in the pores and they pass slowly through the column. The most important parameters to consider in this technique correspond to the chemical stability of the phase materials. The pH, viscosity, temperature, or flow of the element must be taken into account to know to not to not have a lower efficiency of the column.